So for solving this problem, let us look at the free body diagram of the cone. And this is a cone having semi-vertical angle, or the semi-angle of the semi-angle of the cone is alpha, and this is the center of gravity of the cone. And let's look at the forces acting on it. So these are the forces acting on the cone. The weight is mg, and the normal reaction N, and the friction force F. And if you look at this center of mass of the cone, this is having an acceleration towards the center of the circle, as the center of mass of the cone is in a circular path, and the axis of rotation is this vertical one. So the acceleration of the center of mass of the cone is in this direction. So let it be A. So let A be acceleration of center of mass of the cone. Okay. And its length and its distance is given. Actually, distance is given. See here in the problem, the center of gravity or center of mass of the cone is at same level and at a distance L from it. So the distance here given is L. So we can write the acceleration of the center of gravity or center of mass of the cone is omega square multiplied by L. And then we can resolve the forces in the following way. So as this is a semi angle of the cone, so this angle is also alpha, because this angle is 90 degree minus alpha. So the normal force, and so the normal force will have components. Let's split it up into components. So only I am drawing the center of mass of the cone and the forces. Later on I will resolve these forces. So this is force N, this is force mg, and I draw through this point itself. This is the frictional force F. So now let's resolve this N into components and also resolve the friction force into its components. So the components of the normal force, so this angle is alpha, so this angle is also alpha, as this angle is alpha. So this so that is n sine alpha, vertical component is n cos alpha, and this is f sine alpha, and the horizontal component is f cos alpha. So we can write f cos alpha minus n sine alpha is equal to m into a. That means acceleration of center of mass of the cone, that is omega square L. So let it be equation 1. And the second equation, so mg, or this f sine alpha, rather f sine alpha plus n cos alpha is equal to mg. Let's name it equation 2. Now we have to so in part A we have to find the static friction acting on the cone. So to find F you have to eliminate N. So multiply equation 1 by cos alpha and equation 2 by sin alpha. This is what you get. Equation 1 by cos alpha, so F cos square alpha minus N cos alpha sin alpha is equal to m omega square L times cos alpha, and multiply equation 2 by sin alpha, so F sin square alpha plus N cos alpha sin alpha is equal to mg times sin alpha. So we can add the two equations. You get F is equal to m times omega square L cos alpha plus g sin alpha. So this is the answer to part A. So we have found out the value of F friction. Now for finding the value of normal reaction, what we do, we multiply equation 1 by sin alpha, so that is F sin alpha cos alpha minus N sin square alpha is equal to m omega square L sin alpha, and also equation 2 you multiply by cos alpha, so F sin alpha cos alpha plus N cos square alpha is equal to mg times cos alpha. Now you can subtract the two equations. So quickly subtract the two equations. So that is, here you add a minus sign to the first one, here it is plus, here it is minus. So what you get here, these two terms will cancel, or N is equal to m multiplied by g cos alpha minus omega square L times sin alpha. So we have also found out N. Now in part B it is asked that at what values of omega the cone will roll without sliding if coefficient of friction is known. So we can go for the inequality, that will be enough. That is that F is less than equal to mu times n, so it's k, coefficient of friction, so F is less than equal to k times n. So so here you get m, so we can get rid of this m actually. So m is in both sides, so omega square L cos alpha plus g sin alpha is less than equal to k times n, so kg cos alpha minus k omega square L times sin alpha. So you can bring in omega square times L cos alpha plus k L sin alpha is less than equal to kg cos alpha minus g sin alpha. So that is therefore for no slipping or for no sliding, this is the condition. Omega is less than equal to square root of this g, and here you have k cos alpha minus sin alpha divided by L, and here you have cos alpha plus k sin alpha. So that is just a bit of simplification. This term you can write g by L and divide by cos alpha. So you get k minus tan alpha divided by 1 plus k tan alpha.